Welcome back again to this new video. Today we shall learn about Nernst equation. What is Nernst equation? Actually, Nernst equation helps us to determine the cell potential, that is E cell, for any cell, electrochemical cell. So let's have a look at first about the Nernst equation for any individual electron. You have to remember, first we are considering about the individual electron. For example, you can say about zinc electrode or any copper electrode, which is also may considered as an half cell. So first we shall write about Nernst equation for a half cell. Then we will write the Nernst equation for a complete cell. So let's have a look. Here I have generalized an ionic equation for any individual electron, which can be written in this manner, where n represents the charge or the number of electrons. So we can write in this way: m to the power n positive aqueous, because it is ionized. So aqueous plus Me, and forming this electrode. So the Nernst equation for this electrode can be written in this manner: E Mn plus slash m equal to E naught Mn plus slash m minus RT by Mf ln 1 upon m to the power n positive. So here we can do one thing. R is a universal gas constant, T is the temperature that is in the STP standard state, and N is the number of electrons, and F means the Faraday. So this is the charge we have considered here. We can do one thing. In place of R, if you put this value 8.314, then in place of T, if you put 298 Kelvin, and in place of F, that is 1 Farad is equal to 96500 Coulomb, if you put these values, replace here, and in place of ln, that is Napier's logarithm, if you consider the general log, that is log base 10, then the value comes out as 0.059 divided by n. So this is the another equation which we can utilize to solve the numericals. You can use any one of them. I think the more fruitful or the beneficial one is this one. You can utilize it for solving numericals. So here I have shown one example where you can see for copper electrode, the potential can be written in this way: E naught for this copper electrode minus 0.059, as we already got here. And what is N? N is equal to 2. So if you write here 2, so there should be log 1 upon charge of copper electrode. So this is for any individual electrode. Now you may write for any other electrode if you want. For example, say zinc electrode, aluminum electrode, silver electrode, nickel electrode, and many more. For hydrogen electrode also you can write. Now let us see how to write for a complete cell. As I already said, for a complete cell we can write in this way: E cell is equal to E naught cell minus RT by Mf ln oxidized ion to the power its coefficient divided by the reduced ion to the power of its coefficient. And here in place of this we may also write in this manner, as we already discussed over here, by considering this value: 0.059 divided by n, and logarithm of oxidized ion to the power its coefficient divided by reduced ion to its coefficient. For example, if you consider an ionic equation for a complete cell, zinc electrode plus copper ion, which is giving us zinc ion and copper. So here if you see, students, which is oxidized, zinc is oxidized. Zinc is oxidized to zinc ion, and copper ion is reduced here, because charge is, oxidation number is decreased here. So we can write for this cell, E cell is equal to E naught cell minus 0.059 divided by 2, because you see, if you consider here, the coefficient is 1, and what is the charge? 0. 1 into 0 is 0, you can, that is 0, and 1 into 0 you can consider 0, and that is 1 into 2, that is 2. So 2 minus 0, that is comes out as 2. So we can put it here: 2, that is 2 electrons are utilized for oxidation as well as for reduction. So which ion is oxidized? Zinc. Zinc metal undergoes oxidation to give us zinc ion. So according to the formulas, oxidized ion divided by reduced ion. Which is reduced? This ion is reduced, undergoing reduction. So copper 2 plus we can write. And what is the coefficient over here? That is 1. We can write 1 here. And what is the coefficient here? 1. So we can write 1. Now here I would like to tell you one more thing, students, that here we might also write about this copper electrode over here and about zinc electrode in this place, but we have not written or not considered here about this electrode and this electrode, because you see these electrodes are in the pure form, that is in the solid state. So its concentration, as we already learned, is considered as unity. So this electrode should not be written over here. Simply we will write only about the ions which are having their definite concentrations. So we must remember this. So we'll be writing about the ions along with this square bracket. The square bracket represents the concentration. So this way we can calculate the E cell for any kind of cell if E naught cell is known to us. So this is about E cell for a complete cell, and this is about the individual electrode. I hope this video will definitely help you. If you find any doubt, you can inbox me. Thank you very much.